Module 8, Lesson 1 covers vertical angles and adjacent angles. The pacing guide is claiming this is going to be a 2-day lesson, and it looks like we've got 21 resources to get through, so it very well may be. When designing a roller coaster, engineers need to know about the geometry and how to use angles that will support the ride. Engineers like to take into account the materials used, the height of the roller coaster, and whether or not there are inversions or loops in the roller coaster when they decide the angle measures needed to support the coaster. They may use different combinations of vertical and adjacent angles to ensure the safety of the ride. Now, no matter how they build it, I guarantee you, oh wait, we got a video here. No matter how they build it, I guarantee you I won't be on it. I don't do roller coasters. Nope, not going to happen. What other careers require an understanding of geometry and angles? Well, there's a bunch of them out there, I'm sure, but we're not going to talk about all those because we've got some real math to learn today. The hands on a clock form an angle. The vertex is the point at the center of the clock where the hands meet. That's a vocab word. At different times of the day, the angles formed could be obtuse, vocab word, acute, vocab word, right, vocab word, straight, vocab word, and here's a new one for me, the zero angle. I have never seen a zero angle before. That's a totally new concept to me. I always never really liked the straight angle either because, I mean, it's a line. It's not an angle, it's a line, but hey, nobody asked my opinion here. So let's see here. We need to take a look at this one. Move the clock hands. That is going to be a zero angle because it's going to be no space in between them at all. This one here is going to be a acute little angle, otherwise known as acute. This one is going to be a straight angle because it makes a straight line. This one's going to be an obtuse angle because it is a measurement greater than 90 degrees and less than 180. And then our right angle, that's going to measure exactly 90 degrees. Now, all these terms are terms you should be familiar with, except probably the zero angle. Everything else you should have already used in elementary school. Now, an angle can be named a lot of different ways. One of the ways you can name it is using 3 capital letters. Let's go ahead and highlight that whole statement there. So for this one, they've got the letters coming from the 3 points on the angle. 1 point from the angle is going to be the vertex and 1 point from each ray. The middle letter, and this is important right here, your middle letter must be your vertex. So Y in this angle has to be the middle letter. So also we have this symbol right here. That symbol is an angle. So we've got this, the name of this angle here would either be angle XYZ or it'll be angle YX. It would be read as angle XYZ. You could also call that angle ZYX. And whether your textbook shows you or not, it can also be just called angle Z. So there's 3 names for that angle. Angle XYZ, angle ZYX, and angle Z. Oh, angle Y. I'm sorry. We always name it off the middle angle. So what does this say right here? Well, let's see here. They're showing where you start with a Z. After the Z, you move to the Y, and after the Y, you label the X down there. And let's see here. Click here to see the same, another way to name the same angle. There we go. So we're going to start with the X on this one. Then we're going to hit the Y after that, and after the Y, then we're going to get to the Z. And let's go back to the beginning, Z, Y, X, but you could also just name it angle Y based off of the size of that, not the size, but the name of the vertex, that point that's in the vertex. And it looks like the textbook's talking about that right here. It says an angle can be named using only one letter, that letter of course being the vertex. So for this one, we would have angle S. It says select points on the angle to see various ways the angle can be named. So we could name it as angle RST, we could name it as angle TSR, or we could just call it angle R, or in this case it could also be called angle 3. Why they have a 3 in there, I have no idea, because that's normally where we put the size of the angle, but yeah, okay. Example 1 wants you to name this particular angle 4 different ways. So the first option we have here is that we can take and name it based off of this number right here, which is angle 1. That would be good. We could call it angle XYZ, and you see that right there. We could call it angle ZYX, and you see that one right there. Or we could call it just angle Y, which is located right there. The others, while they have 3 letters on these two, you do not have your Y as a middle term. The Y has to be a middle term when using 3 points. And if you're using a single point, that single point has to be the vertex of the angle. Now it's going to be your turn. Take a look at this angle here and figure out all the different ways that you can possibly name that angle and get away with having a good answer. How'd you do? Well, first off, we could go LMN, which is option 1. I could go NML, which is option 3. I could just call it angle M, which is option 5. And we could call it angle 4, which is option 6. Check it. Our answer checks. Easy math on these things. From here, we get an inquiry question that says, what are some relationships between pairs of angles created with intersecting lines? And there's several of them that we get to learn about, and these are some pretty, you're never going to use them outside of math, sorry. But in math, you still got to know how they work. So it says, drag the angle names to identify angles created by the intersecting lines. Well, first I see angle BED, so I can take a BED there, and I have a DEB, which is not an option. I have a BEC, which is right there. I have a CEA, which is not an option, but AEC is. And I have a DEA, not the Drug Enforcement Agency, otherwise known as the AED. Now for this one, they have a B in the middle. Nope, B is not a vertex. They have a C in the middle. C is not a vertex. So those are going to be your 4 correct angles for that part of the problem. Now if we keep moving on, we're going to take and compare angle AEC. That's going to be AEC and angle BED here, this angle here. And what do you notice? Well, what I notice is those two look to be the same exact size angle. And they are, in fact, going to be the same exact size angle. Same thing if you were to take and compare angle BEC right here and angle AED right here. These two angles also appear to be the same exact size angle. These are known as what we call vertical angles. Angles that appear on the opposite sides of 2 intersecting lines are going to be called vertical angles. They are on opposite sides of the vertex. I'm going to highlight that. And we could also say that another pair of vertical angles that are taking place in there, that's going to be those two as well. So we can make a conjecture about these angles here, and that is that angles on the opposite sides of 2 intersecting lines, or opposite sides of the vertex when you have 2 intersecting lines, are going to be congruent. Of course, congruent is nothing more than a fancy word for equal. They're going to be the same size. Next, we're going to take and compare some more angles. We're going to look at angle BEC, that is this big one right here, and we're going to look at angle AEC, that's the big one right here. And they ask, what do we notice about them? Well, if we took and added BEC and AEC together, we get this straight line. And the measure of a straight line is 180 degrees. We call these two angles supplementary angles. We also call them adjacent angles because they are adjacent or side by side here. And the adjacent angles that occur anytime you get 2 intersecting lines are always going to equal 180 degrees. And yep, that's pretty much what they wanted us to say right there. The angles here are called an adjacent pair. We're going to go ahead and highlight that. And they share a vertex and a side, and I'm going to go ahead and highlight that. There's another set of adjacent angles. In fact, there's lots of them here. You could say angle CEA and AEC make an adjacent angle. You could say angle AED and DEB make an adjacent angle. Any set of angles that are side by side when you have two intersecting lines are going to be adjacent angles, and the sum of their measures is always going to equal 180 degrees. And now it's time for actual proper definitions of these. Two angles are vertical if they are opposite angles formed by two intersecting lines. Remember, they're on opposite sides of the vertex. And then vertical angles are going to be congruent, and congruent, of course, are angles that have the same measure. So anytime you have two things that have the same exact measure, they're said to be congruent. When we take a look at these buttons down here, we're going to compare angles 1 and 3, and it says that angle 1 is congruent to, that's what that symbol means, is congruent to angle 3. And now we're going to throw in a new concept, and that's when we put an M in front of the angle. And when you have an M in front of the angle, it means the measure of angle 1 is equal to or congruent to the measure of angle 3. Anytime you have equal signs with squigglies above it, that means is congruent to. Now, we could also say that the measure of angle 2, this one right here, is going to be congruent to the measure of angle 4. They're vertical angles. They are angles that occur on the opposite sides of two intersecting lines. And we could note the vertical angles share a common endpoint, that black dot right there. And how could you name that endpoint? How do you name or describe that endpoint to a classmate? Well, that's a really good question, because that is going to be angle 1, it's going to be angle 2, angle 3, and angle 4, depending on how you look at it. So I'm not real sure how you describe that to a classmate. So let's take and try identifying some vertical angle pairs here. Taking a look at it, the diagram shows 3 different intersecting lines. Wow, okay, this is going to make it even more fun. And we need to identify vertical angle pairs by dragging each angle label from the diagram to its matching vertical angle. So angle 1 is going to be, that's going to be angle 4, because angle 4 is on the opposite side of the intersecting lines. Angle 2 is vertical 2, that's going to become angle 5. And angle 3, that's this one here, is going to be vertical to angle 6. And check, it really is that simple. Now it's going to be your turn. Do extra example number 1, just like I did example number 1. Was that easy or what? Let's say angle 3, opposite of angle 3, is going to be angle 6. That's a vertical angle. The opposite of angle 4, that's this one, is going to be angle 1, the vertical angle. And the opposite of angle 5, that's this one, is going to be angle 2, the vertical angle. It checks. Easy math. Anybody can do this stuff. And now is where things start getting a little bit fun, and it's going to require you to understand these concepts. We're going to use the vertical angles and adjacent angles to find the missing measures, and we got a video to tell us how to do that.
You can use vertical angles to find an unknown value. Vertical angles are opposite angles formed by a pair of intersecting lines. Angle AEB and angle CED are vertical angles. Write a congruency statement about the vertical angles. Vertical angles are always congruent. This means they have the same measure. Write an equation by substituting for each angle measure. The measure of angle AEB is 75 degrees. The measure of angle CED is given by the expression 4x minus 5. The last step is to solve the equation to find the value of x. The value of x is 20.
So in reality, we've not really done anything new here. They didn't really show how they isolated the variable on that one. But despite that, this is all concepts we know how to do. The only thing we've added is the concept that these two vertical angles are congruent. From there, they set them equal to each other, use their big kid math to properly isolate the variable, and get x is equal to 20. And that leads us into example 3, where we're going to write and solve an equation for the value of x. You see you've got two vertical angles here. That means that the sum of 2x and 2 is going to equal to 130. From there we set them equal to each other and we isolate the variable. So let's take a look at that. We're going to write the equation as, let's see here, we got 2x plus 2 is equal to 130. That's going to be our equation because you got the 2x plus 2 on one side, the 130 on the other. That part's going to check. And from here, it's just a matter of isolating the variable. Now, they threw an awful lot of stuff going on in here. They took and subtracted the 2 on both sides, but you should already know how to do that. These 2's are going to zero each other out, leaving 2x is equal to 130 minus 2 was 128. Then they took and divided 2 on both sides to finish isolating the variable. The 2 divided by 2 is 1. 1 times x is x. And 128 divided by 2 is 64. So your final answer is going to be x is equal to 64. Of course, that is showing your work. That is what I must see if you want to have credit for it on your homework tonight. And now it's going to be your turn. Take a minute and pause this video and work on this problem on your own. Alright, so looking at my problem, I've got two vertical angles that are identified here, and we just need to take and find the sum of them. And, whoa, hold on. So from there, we're going to set it up as, on one side, I'm going to have the sum of 2x and 4, and that's going to be equal to 100 on the other side. We're going to undo addition and subtraction by subtracting 4 from both sides. When we do that, those 4's zero out, leaving 2x is equal to 100 minus 4. That's going to become 96. Next, we're going to undo multiplication and division by dividing by 2 on both sides. When I do that, those 2's divide out, becoming 1. 1 times x is x, and 96 divided by 2, that is going to be 20, or not 23, that is going to be 48, I do believe. Yep, 48. So 48 is going to be the final answer for x. Jump back over to our textbook, type in our 48, check our answer. Oh, hold on, we got more things going on here. Let's write an equation first. Our equation was going to be 2x plus 4 equals 100. So I have 2x plus 4 equals 100. Check that. And now when we do that, we had x is equal to 48. That's going to be our final answer. Easy math. This is going to be a good place to stop part 1. When we come back to part 2 of this video, we're going to learn more about solving adjacent angles and how adjacent angles work. I'll see you in part 2.